Hey, pre-calc honors. Okay, so we are recording 3.7. This is called implicit differentiation. The word implicit means it's imply, okay? The word implicit means it's imply or understood. Okay, so implicit differentiation is a process, we use when we are trying to find the derivative of a function that has not been clearly defined. We are not told what the function is, okay? But it is implied that it is a function of x. Okay, so it doesn't say, oh, find the derivative with respect to x, okay, or I'm sorry, it doesn't say that, oh, y equals, and then the input is x. It doesn't say at all which one is the input and which one is the output. But we will just assume anytime you see an equation with y and x in it, we will assume, or implicitly assuming that, hey, x is the input and y is the output, okay? So the process is, step 1, differentiate both sides with respect to x. Then step number 2, collect all terms with dy dx on one side of the equation. This step is not always done, okay? Not always. Factor out your dy dx if there is more than one. Then last one, solve for dy dx, okay, which is the same as y prime, which is the same as d over dx, which is the same as d of x over df over dx. So because in the final solution, we are trying to take the derivative of y with respect to x, but the word implicit meaning that it's going to give you an equation that you don't know, hey, is this a y equals, is it an x equals, okay? So an example of that is right here on number 1. Find the derivative with respect to x for this equation. Notice how it's not written as y equals, okay? So this is the type of equations that we're talking about. We are going to assume, imply that x is the input, so that's why we are trying to take the derivative with respect to x. So step number 1 said, hey, you know what, do the derivative, differentiate both sides with respect to x. Because we are taking the derivative with respect to x, 3x to the third is now 3x squared plus y to the third. Okay, so this is the part where you have to be very careful. Y to the third is not with respect to x. We are still using the power rule, but we still need to find the chain rule of y, okay, y prime. So y to the third, the derivative of y to the third is 3y squared times y prime equals the derivative of 18xy. So we can pull out the constant, and then we can do the product rule. So y prime times y plus, x prime times y plus y prime times x. And from here, we're slowly going to see if we can combine some things. Okay, so 3y squared stays times y prime. I'm going to write that as dy dx, okay? Because later I would have to move it to one side. Equals 18 stays out the same. X prime, the derivative of x, is 1, okay? So the derivative of x is 1 times y plus y prime is y prime times x, okay? So that's the difference between these two. So let's go back and check. See this right here? The derivative of x prime is 1, but the derivative of y prime maintains as a y prime because we are taking the derivative with respect to x, okay? So from here, we are going to see if I can, I'm writing everything down so that way you can see, especially coming from a video notes, I'm not in front of you. 1 times y is y. Y prime is now, I will change that to dy dx, okay? And then I'm going to write x in the front, like that. Okay, so from here, I will distribute the 18. So 3x squared plus 3y squared dy dx equals 18y plus 18x dy dx. And the strategy number 2 says, hey, collect all terms with dy dx on one side. So you can decide, you can move it to the right, you can move it to the left. It doesn't matter, you have to pick one. So I'm moving this over here, and then I'm moving the dy dx over here, okay? So when I do that, I have 3y squared dy dx minus 18x dy dx equals 18y minus 3x squared. Then I'm out of space, so this goes here. Then step number 3 is it's not always, but in this case we are going to factor out dy dx. So take out your dy dx from the left side. You're left with 3y squared minus 18x equals 18y minus 3x squared. Then we are trying to find the derivative, which is dy dx. So we are now going to divide both sides by 3y squared minus 18x. 3y squared minus 18x. Then from here, that's canceling. So dy dx, which is our final goal, equals 18y minus 3x squared all over 3y squared minus 18x. But that's not done because I want to see if I can simplify. So from here, we are going to see if I can factor a 3. If I factor out 3, I have 6y minus x squared all over 3 times y squared minus 6x, okay? Then those are canceling. So here we go. dy dx is 6y minus x squared all over y squared minus 6x. Okay? Or some of you can even write this way. Negative x squared plus 6y all over negative 6x plus y squared, right? So this is preferred. If you write it this way, then you need to just cancel out the negative, so you can end up with a positive x squared minus 6y all over positive 6x minus y squared. This or that would be okay. Either one I will totally accept. Okay, if I'm going too fast, please do hit pause, okay? And then, or better yet, listen to it the first time around, and then the second time, you can come back and copy the notes. Okay, so now that you have gotten a chance to listen to example 1, why don't you try this on your own? So hit pause, do the you try, and then unpause, okay, and then go to example 2. All right, example 2, find the lines that are A, tangent, and B, normal to x squared minus radical 3xy plus 2y squared equals 5 at radical 3 comma 2. So we already have a point, okay? I need the slope. The slope is really finding dy over dx, right? So, which is y prime. So let's do that first, okay? So let's try to find dy dx. Because the tangent line, I need the slope, and normal is very similar to tangent, except the normal is the reciprocal and opposite slope. So first, let's find the derivative, okay? So here's the equation. X squared, the derivative of that is 2x, okay, minus radical 3xy. I'm going to factor out a radical 3, and I'm going to use the product rule. So it's going to be x prime times y plus y prime times x. Plus, the derivative of 2y squared is 4y, subtract power 1 from 2, so still 1, but you need to multiply by y prime. The derivative of 5 is 0. Remember, you have to take the derivative to both sides. So from here, I will try to see if I can combine or distribute anything, okay? X prime is 1. So now it's negative rad 3 times 1 times y plus y prime. I'm going to change that to dy dx, okay, and put x in the front. Plus 4y, change y prime to dy dx again, because it's the same thing. You don't have to. I do it so I know that I want to make sure dy dx are always on one side. Then from here, I'm going to distribute the rad 3. So rad 3 times y is negative rad 3y minus rad 3x dy dx plus 4y dy dx, okay, equal to 0. Then from here, I'm going to move everything that's not dy dx. So that means this is going to go over here, and also this is going to go over here. So with that said, I will now have a negative radical 3x dy dx plus 4y dy dx. Okay, if I move the 2x over, it's now negative 2x. If I move the negative radical 3y over, it's now a positive radical 3y. Then from here, I will now factor out, let me just erase, from here, I can just factor out your dy dx. Oops, I need to add x right there. Okay. So they have dy dx in common, so factor it out, because that's, we will have to solve for dy dx, so that will represent the slope. Okay, over here I have negative 2x plus radical 3y. Then I will now divide both sides by negative radical 3x plus 4y, so divide by here, negative radical 3x plus 4y, negative radical 3x plus 4y. Okay, so I will now have dy over dx, okay, equals, I don't like to have negative in the front, so what I'm going to do is I'm going to change the sign to all of this, okay? So now I would have positive 2x minus radical 3y all over positive radical 3x minus 4y. So that is the derivative of any xy point, okay? But for our problem, they want you to evaluate when x is at radical 3 and y is at 2, because it wants to find the slope at that one particular point. So when I plug in, so dy over dx is the same as slope now, is 2 times x is radical 3, okay? minus radical 3, y is 2, okay, all over, on the bottom, I have radical 3, y is 2, minus 4 times, oops, I'm sorry, that's x, radical 3 times x is rad 3. Okay. Minus 4 times y, which is 2. Then let's simplify. Here we go. That's going to be 2 rad 3 minus 2 rad 3. Oh my goodness. That's 0 on the top. Okay, so this is really 3 minus 8. But that doesn't really matter, right? This is 0. Okay, so 0 over negative 5, which is really 0. Yay! Because that's easy. Yay! Okay, so your slope is 0. So how do I find the tangent? Part A. Tangent. Y minus y1 equals slope times x minus x1. Y minus y1 is 2 equals slope is 0. X minus radical 3. Well, that goes to 0, so y minus 2 equals 0. So the tangent line is y equals 2. Beautiful, isn't it? Now, the part B says normal, okay? Normal means the slope is opposite and reciprocal. The reciprocal of 0 is undefined. Okay, so I'm not going to have a slope. But when you have a tangent line of y equals 2, it looks like this. This is what y equals 2 looks like. It's a horizontal line. So a perpendicular slope is going to look like this, right? So the slope is undefined, but look, it just crosses over at the x-axis. So all you need to know is that x equals radical 3, and that is my normal line. Okay? And again, if this was confusing, just listen to it one time first, then go and write the notes. Okay. Now that we have done example 2, try the U-try. And in class, we will go over the U-tries, all of the U-tries, okay? But give it a shot. So what if it's wrong? You can correct it again in class. Example 3. The last video, we talked about you guys trying out the U-try. Did you guys come up with the tangent? It's y. If I write it as y equals mx plus b, if y equals 3 over 4x minus 25 over 4, and the normal is y equals negative 4/3 x. Of course, I will always accept the answer in point-swift form. So don't worry about if you put it in point-swift form, as long as it is equivalent to those answers, okay? So today, we are going to talk about example 3, or at least on this video. Whether it is assigned the same day or not, that is to be determined. Use the implicit differentiation to find dy over dx, and then also the second derivative. So I'm going to need a lot of space, so I'm going to write. Okay, so I'm going to write this question again over here: x to the 2/3 plus y to the 2/3 equals 1. So I'm going to do the derivative, the first derivative. So the power rule says I'm going to drop down the power times x, subtract 1, so negative 1/3, minus 2/3, why am I saying minus? Drop down the power, positive 2/3, I'm sorry, times y to the negative 1/3, that's what my brain's saying. Now, because I am doing the derivative with respect to x, I need to multiply by y prime, or dy over dx. The derivative of 1 is always 0. Our goal is obviously solve for dy dx because it says to find dy dx. So the first thing is I'm going to subtract this right here to the other side. So if I subtract that, I keep 2/3 y to the negative 1/3 dy dx equals negative 2/3 times x to the power of negative 1/3. I will get rid of the fractions first, so multiply both sides by its reciprocal, 3 over 2. If we multiply by its reciprocal, I now have y to the negative 1/3 dy dx equals, if I do that, cancel, 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 cancel. So negative x to the negative 1/3. Now divide both sides by y to the negative 1/3, okay? So our dy over dx is, I can keep this as, no, remember, I don't want your answer to ever be a negative exponent unless you can't help it. So they're both negative exponents, so I'm going to rewrite it so that way it's a positive exponent. So I can move the y to the numerator and move the x to the denominator to make all the exponents positive. If you like radical better, by all means, you can write it like this, okay? You can write cube root of y, negative cube root of x, negative cube root of y divided by positive cube root of x. So that's the first derivative. Next, we are going to try to do the second derivative, which again, I still need lots and lots and lots of space, okay? So the second derivative is, I'm going to take, obviously, the first derivative and do sort of a quotient rule. So I'm going to let u be the numerator, which is negative y to the positive 1/3 power. So u prime would mean negative 1/3 times y to the negative 2/3 times dy over dx or y prime. V, I'm going to let it be the denominator, which is x to the 1/3. That means v prime is 1/3 times x to the negative 2/3. Since it is with respect to x, I do not need to write x prime, okay? Now I'm going to rewrite the quotient rule. Oops. I'm trying to do second derivative. d square y over dx squared. So the rule says u prime times v minus v prime times u all over v squared. I did all the background work already. Now I just have to plug in what u prime v prime u are, okay? So u prime is this whole thing right here, negative 1/3. I'm going to write a lot of steps out, dy dx. So that's u prime times v, and v's is not as ugly, it's just x to the 1/3, no big deal, minus v prime, which is 1/3 x to the negative 2/3 times u, which just happened to be a negative y to the 1/3, okay, all over v square, and v is x to the 1/3 to the square. Okay, now this is the step where I have to like really take my time and double check my work. Okay, so this right here and this right here, I'm going to put them together to the front. And normally when I write stuff, I like to write x in front of y, so that's why I'm just moving it in front of the negative y to the negative 2/3. And then multiply by dy over dx minus, now this is a part where two negatives will change it to a positive. So that's going to be positive 1/3 maintains in the front. I like to write x first, then y to the positive 1/3. All over on the bottom, power to the power, I'm just going to multiply them. That's really x to the 2/3. Okay. So I will, technically, I can even divide all of that right there, x to the 2/3. Okay, let's go see how far we can go. So from here, do you want to simplify first and then plug in dy dx, or do you want to plug in dy dx and simplify? That's really a personal choice. Well, since I already, looks like I highlighted already, why don't I just plug it in first? Oops. Why don't we go and find dy dx? And where the heck is dy dx? Orange. dy dx is back to over here. dy dx. I'm going to plug that in. Okay. So pinch it in so I can see what the whole dy dx is. Whee. negative 1/3 x to the 1/3 y to the negative 2/3 dy dx. Here we go. Negative y to the 1/3 all over x to the 1/3. That's dy dx. I'm just writing that all in, okay? Then I'm going to copy everything else over as is. Positive 1/3 x to the negative 2/3 y to the 1/3 all over x to the 2/3. Now, as you can see, I can get rid of those. Those two guys would be canceled. So now, next step, 1/3 negative. Those x's are already gone. So, but actually, this negative and that negative is now going to be a positive. I'm working this out as I'm writing. So, okay, so positive 1/3. Now, y to the negative 2/3 times y to the positive 2/3. The y's are the same, so I'm going to add the exponents, okay? When I add the exponents, negative 2/3 and a positive 1/3 is now a negative 1/3. So that's all I have left on that piece. Then I'm just going to copy everything else. Oh, ignore this thing right here. This thing belongs to that top. So then I'm just going to copy everything over, and we will now simplify the denominator. How about if we were to do this? Okay, would you be okay if I divide, if I divide each side like this, x to the 2/3, x to the 2/3, okay? Then, if it's a negative exponent, I will bring it to the bottom. Just like that guy has a negative exponent, just that guy. So here's the next step. 1/3, x to the 2/3. I'm going to bring y to the bottom to make it positive, plus 1/, the 3's on the bottom, x to the 2/3 on the bottom, bring out the other negative to the 2/3, and then y to the 1/3 on the top. So that's what I now have, okay? If I brought this on the bottom, can you make this a positive right here? Now, I will try to simplify as much as I can, okay? Let's continue with the basic algebra here. On the top, I have 1/. On the bottom, I have 3x to the 2/3, y to the 1/3. Then on the top over here, I have y to the 1/3. On the bottom, I will add those powers. That's really 3x to the 4/3, just like that. Then, looks like I might need to find, let's see. I need to find a common denominator. Are you okay with that? Okay. So what would happen if I find a common denominator? This side right here has x to the 2/3 already, so I don't need to multiply, but I'm going to multiply this side by y to the 1/3 and this side by x to the 2/3. What I multiply to the bottom, I multiply to the top. Okay, there you go. So now, next step, are you ready? Common denominator. So 3 is already there. X to the 4/3, y to the 1/3. Okay, that's on the bottom. On the top, I have x to the 2/3 plus these two. The bases are both y's. I mean, I can add the exponents. So that really becomes y to the 2/3. Well, y to the 2/3, can't really stop right there now, could I? Y to the 2/3 really become, this is the part where it's super important. Whoop, 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 whoop. That right there, and whoop, 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 right there. I have to use substitution and plug it back in. So this is 1/, because x to the 2/3 plus y to the 2/3 is 1. So I have to take that out and put it 1, because that's even simpler. 3x to the 4/3, y to the 1/3, and I think that's as far or as simple as I can go. That is the second derivative. So the takeaway is this, guys. The takeaway is, I'm going to use a different color, okay, to highlight. Pay attention to where dy dx was. Use that to substitute with the original. Then, once you get to the final answer, double check to see if I can use the original question to substitute again. So those are the two locations that you need to be very careful about. And this is the end of example 3.